So here I have drawn the graphs of y equals x squared as well as y equals 6. So the green graph is the graph of y equal to 6x x squared, which is basically a parabola. And the blue line, which is the graph of y equals 6. So if suppose we inscribe a rectangle that is ABCD inside this bounded region between the graph of y equal to x squared and y equal to 6. So it will look like this. So this is the rectangle, and we have to find the maximum area of this rectangle. So to find the maximum area of this rectangle, we need the expression for length and the height of the rectangle. Uh, the length of this rectangle is AB. Let's consider this as AB, and the height of the rectangle is BC. So we can determine the length AB in terms of this given curves, that is the y equal to x squared as well as y equal to 6. So basically this distance is x. So that is the half of the length equal to x, and another half of the length is also x, which means the total length AB equals 2x. So you can write down the length of the rectangle as 2x, and the height of the rectangle, which is BC, this height is equal to this overall height, that is y equal to 6, minus the height of this height given by this graph of y equal to x squared. So basically this distance, that is this distance, is equivalent to the overall height, which is 6, minus the height of this graph of the parabola at any point, that is given by this equation x squared. So we put 6 minus x squared. So therefore the height of this rectangle is given as BC equals 6 minus of x squared. So now we got the value of length and the height of the rectangle. So you can write down the area formula of the rectangle. So area of the rectangle, this equals length times the height. BC is the height, so we can write down this as height of the rectangle. So let's substitute the length, which is 2x, and height of the rectangle is 6 minus of x squared. We can simplify this by distributing the 2x. So 2x times of 6 is 12x, and 2x times of negative x squared is negative 2x cubed, because x times x squared is x cubed. So basically this is the expression for the area of the rectangle, which I'm going to call this as area function a of x. And now we have to use the calculus first derivative and second derivative method to find the maximum area of the rectangle at some point of x. So for that, let's find the first derivative of the area function. So we find a prime of x. This is the first derivative of a of x. So this equals, we have to find the derivative of 12x, which is 12, minus derivative of 2x cube using the power rule is 6x squared. So this is the expression for the first derivative. And to find the critical numbers, we have to set up a prime of x equal to 0. That is, the first derivative equals 0, and then we find the corresponding x. So let's replace a prime of x equal to 0. So therefore this becomes 0 equals 12 minus of 6x squared. And from this we solve for x. So this basically gives 6x squared equals 12. So x squared equals, we divide both sides by 6, we get 2. We then take a square root to determine the value of x. So we take square root. So we'll get the two values of x, that is x equals plus or minus square root of 2. We will now decide which value gives the maximum area. So for now we consider the critical points as x equal to positive root 2 and negative root 2. And then we will use the second derivative test to determine at which point the area is maximum. So we have to find the second derivative of the area function. So I write down a double prime of x. We can find the derivative of this function. So it becomes the derivative of 12 is 0, and derivative of negative 6x squared is negative 12x. So basically the second derivative is negative 12x. Now we plug in each value of x into the second derivative, and if it comes positive, that is a double prime of x is greater than 0 at this value of x, then we say it is minimum area. or otherwise if we plug in x into the second derivative, and if it is less than 0, that is if the sign is negative, we say that the area is maximum. So let's find this out. This is the rule that we follow. So I'm going to plug in x equal to root 2 into this second derivative. So therefore this becomes a double prime of positive root 2, and this gives negative 12 times of x is root 2, and this is a negative quantity. So this comes to be negative, which means at this point area is maximum. So at x equal to root 2, the area is maximum. We say that the area is maximum. We can verify by substituting the second value, that is at x equal to negative root 2. So therefore this becomes a double prime of negative root 2, and this will becomes negative 12 times of negative root 2. This is a positive quantity. This is because negative times negative is positive, and this basically gives 12 root 2. And this means it satisfies this condition, which means it is a minimum point. Since we are looking at only the maximum area, we can ignore this. That is, we can ignore this critical number for now and consider only the value of x, which gives the maximum area. So I'm going to consider this x equal to root 2, which helps to maximize the area of the function or the area of the rectangle. So now let's find the maximum area. For that we have to use this area function. So let me copy the area function. We have a of x, and this equals 12x minus of 2x cube. So to find the maximum area, we have to plug in this critical number which we found in previous steps into this area function. So when we do that, we get a of root 2, and this equals 12 times of root 2 minus 2 times of root 2 quantity cube. You'll simplify this. So this is 12 root 2 minus of 2 times of root 2 cube is 2 power 1 by 2 raised to the power of 3. So this is 2 power 3 and square root. So this can also be written as 2 times 2 times 2 square root. We can factor out a pair of 2 out of the square root. So therefore this becomes 2 times of root 2, which we substitute over here. So root 2 cube is 2 times of root 2, and finally this becomes 2 times of root 2 is 4 root 2. So I can here put this as 4 times of root 2, and these two are like terms, that is 12 root 2 minus 4 root 2, and this is going to be 8 root 2. So we found the maximum area of the rectangle equals 8 root